All right, in this section, we're going to look at adding and subtracting rational expressions with like denominators, meaning the denominators are the same. So let's go back over the basic rule for adding and subtracting fractions, which we already know that a rational expression is a fraction with a common denominator. For example, we have something such as 3 over 2 plus, let's say we have 7 over 2. The rule says that we're going to keep the common denominator, bring together the numerators, and then we have here 10 over 2, and we know that reduces to 5. Keep the denominators the same, bring together the numerators. What's different for rational expressions is that we're going to factor. If it's possible, factor the numerator, and also, if possible, we'll factor the denominator as well. So let's look at the first question. 3 over xz squared minus 15 over xz squared. We have a common denominator, that is xz squared. Let's bring together our numerators. And we have here 3 minus 15, which gives us negative 12 all over xz squared. Now, the numerator and denominator, they are monomials. We cannot factor those, so we're finished with this example. Number 2, we have here 11 over x minus 11 plus x over x minus 11. So what we're going to do is combine or bring together our denominator, combine the numerator, and we have 11 plus x all over x minus 11. Well, let's just go ahead and write the terms in descending order. We have x plus 11 in the numerator over our denominator x minus 11. Now there's nothing that we can do here because they are different binomials. So we are finished with this example. So our solution is x plus 11 over x minus 11. Next example, number 3. We have here y squared over y plus 9 minus 81 over y plus 9. We have a common denominator, that is y plus 9. Bring together the numerators, the y squared minus 81. Now look at the y squared minus 81. Do you notice something? Because remember, the rule says that we're going to factor at the end. So let me clarify something here. In the previous sections, in the rational expressions where we multiplied and divide and then we just reduce a rational expression, well, we factored at the beginning. But when it comes to adding and subtracting rational expressions, we're going to factor at the end. So once we use our rule for adding and subtracting fractions with the common denominator, now we're going to factor. And this is a difference of 2 squares. So let's set up our template. We have opposite signs, y and y for the first term, 9 and 9 for the last term. And then our denominator is y plus 9. And then we're going to cancel all pairs that's common to the numerator and denominator. And what we're going to cancel out is the y plus 9. And then this gives us the solution of y minus 9.